But with that, I think we've got enough people here. We can get started. So we try to mix things up and do different things with these Symposium sessions. And this time we're trying something a little bit new. We're calling it a little release party for Quill for Scala 3. We try to have all the Symposium sessions be fun for some definition of fun involving ZO and functional programming, but we're going to try to make this one a little more fun. We're going to have a presentation from Alex, and then we're going to have a little bit of a panel discussion, and then we're actually going to move over to spatial chat and kind of have more of an interactive thing where all of us can talk to each other instead of this kind of just presenting in Q&A format. So hopefully it'll be really fun. And for this in particular, I'm really excited to have Alex here. Alex has been the maintainer of Quill, which if you haven't used it before, is a library for working with databases in Scala in a type-safe way, where you basically get to like write these queries in kind of a nice way and actually have them like checked at compile time to make sure that like these queries are actually like valid queries in terms of valid syntax and potentially even like the database you're like trying to go against. So really cool stuff there. And he's had a tough job of, this was very macro powered, and that's probably the thing that changed most between Scala 2 and Scala 3. So like there are a lot of libraries, like even ZO, we say like, oh, we supported Scala 3 very early in kind of the Dotty like development process, but like we didn't have to do that much. We kind of compiled for it, and maybe we got a few errors and we reported the errors, and we kind of did our thing to contribute. But Alex, I think, really had to rewrite this whole thing from scratch, and I think in the process kind of identified a bunch of issues with the way that metaprogramming was kind of shaping up in Scala 3, and really significantly shaped the direction of the metaprogramming solution that we have today. And also just like on a personal level, I think I'm excited to introduce Alex. I think I first got to know him last year when I was helping him do like a ZO module for Quill, and it was a real pleasure working with him. It was not just like, oh, how do I do this, but like, well, why are we doing things this way, and exactly how does this work? And there was just like such a level of curiosity and passion of like, we were going like late at night, and he had students from like Drexel who was bringing in, who was like teaching about metaprogramming and type theory. So it's just all this great stuff. So with that, I'll hand it over to Alex here.
Thank you, Adam. Yeah, it's a pleasure to be here. A pleasure to be working with you, Adam. And thank you so much for doing this for me, for throwing this party for me. Thank you, Sandra, for setting it up. The alternative would just have been me sitting on my couch sipping vodka. So this is really good. This is really nice to be able to share this. Yeah, it's been a tough year because basically all the major underpinnings of Quill have basically vanished with Scala 3, and sort of in its place is this new, extremely cutting-edge system, and it's definitely worth it. It's definitely worth all the effort that it took to migrate this thing over, but it's been a tough job, and it's required a lot of changes. But as a result of which, I think the takeaway of all of it is that it is a new era of metaprogramming with Scala 3. There are many, many new things that are possible, like an entire new landscape of things that's possible. And I say that over and over and over again. But I really believe it's true. There are things that can be done now with metaprogramming that 5 or 6 years ago we've only dreamed about. And I want to talk about that and talk about some future possibilities, as well as some learnings from Quill and new things that we've had to do, and the indication of the overall direction of metaprogramming. So by the way, this is a Quill release party, but we actually are already on beta 1.3. So this is the third beta that came out. Right now, we're supporting the regular synchronous JDBC contexts, the ZO contexts for all the databases, by the way, and as well as JA async for Postgres. Monix context, Cassandra context, Tight, all of that is coming very, very soon. So here's what I'm going to talk about. First, I'm going to talk about metaprogramming and sort of I'll start with sort of using Quill as a springboard and then try and go into metaprogramming a little bit more generally and why metaprogramming can solve a whole bunch of interesting problems, a whole bunch of interesting and very useful problems. Second, I'll talk about the Quill context, since that's the sort of primary interface or the primary API to Quill, and it has a lot of pain points. And so I'll talk about a lot of different ways that those pain points have been addressed in Scala 3, and a lot of them don't even exist anymore. And finally, I'm going to talk a little bit about migration from Quill in Scala 2 to Quill in Scala 3 and some of the changes that have to be made. Okay, let's get into it. So how does Quill do what it does? Well, we have these things called embedded DSLs and quoted DSLs. And essentially, a quoted DSL is a bunch of code that goes into a macro, and the macro is called the quotation. I'll illustrate this in a minute. An embedded DSL is more like a traditional DSL that we have with languages that can do things like, make operators or things that look like operators and stuff like that. That's more traditional way to do things. So this is what Quill does, right? You've got your quotation. At some point you execute it and it creates a SQL query, right? Well, how does it actually do this, right? How do we know what the SQL query is? That's the fundamental question that is asked of DSLs, right? Let's look at this first, right? What's this? How do we know what is inside of here? So let's make this a bit longer, right? And there's a good reason to want to know what's inside of an expression if you're giving it to a particular function, right? You might want to pass it to some database or make an API call or transpile it to some other language. There's all sorts of interesting things you might want to know about it. But the question is, how do you? How do you know what's inside here? This is a string. This is a comparison operator. How do you know what actually happened? So I think the best way to illustrate this is with a very short story to essentially show embedded DSLs versus quoted DSLs. It's a sort of parable or conundrum, which is the following. Imagine that there are two thieves, and one of them is sort of the mastermind behind the operation. He figures out how to break into vaults and how to do all sorts of analysis on security. And the other guy, his partner, is the acrobat. He's actually the one that performs the operation. So one fine day, the guy who does the acrobatics and the ops, he's out in the field and he thinks to himself, I don't need this guy that plans all these things. I could figure it all out myself. He's useless. So I'm just going to go back to our hideout and I'm gonna slit his throat. I don't need him at all. Meanwhile, the guy back at the hideout is thinking the same thing. He's like, this guy that executes all of the operations, I don't need him. I can hire anyone. It's all about the planning. It's all about the analysis. So when he comes back, I'm going to poison his coffee. So the guy who does the operations comes back to the hideout, slits the other guy's throat, and then drinks the coffee that he prepared for him and dies. And so it's a conundrum, because how the heck do we actually know what happened, right? How do we know that story happened? How does anybody know that story happened, right? The only two people that knew about it are dead. So This is a funny little story. It was told to be a number of years ago by my rabbi to illustrate some interesting thoughts about human communication. But the point is that, sort of pragmatically speaking, there are two possible solutions. The first solution is they weren't actually doing it, right? They didn't actually kill each other. It was all one giant improv act. And when they got done, they looked at one another and they said, "Oh, wow, this is a great Broadway story. Let's go and make some money selling the script," right? That's one possible explanation. And that's essentially an EDSL. And EDSL is, we have these things that look like strings and ints and operators and methods, and we think that they're executing stuff, but actually they're not. They're impersonating these things. So you'll have two things that will like impersonate integers. And when there's addition, they'll impersonate the addition of those integers. And at the end, we won't get something that's been executed. We will get a recording of what happened. That's the EDSL approach. The Qdsl approach is the other school of thought, which is that no, these events actually did happen. You know, those two guys did kill one another, but the whole thing was recorded on camera. And that's how we know about it. Well, okay. One significant difference is that with QDSLs, you actually you have the recording, and you can actually say at the end of the recording, do I want this story to actually happen or not? And not only that, you can actually say, maybe I want to change some details about it. Maybe I want to change it from coffee to soup or to casserole or anything like that. Maybe they weren't human beings. Maybe they were squirrels. Maybe the entire thing happened in some other fantasy land. Whatever it is, you can change the story and take it through a sort of Photoshop. And then once you're done, you can say, now execute. So that's essentially a QDSL. So, right, here's the problem, right? Here's the name of the game, right? We don't see it if we're just a regular expression that does a comparison. Well, we see a Boolean, right? We don't see everything that happened. We don't see the expression. This is sort of like the coroner's office. This is, what he sees are two cadavers, and that's what we see. We see the output of the expression. So we want to know what happened when we need to know what happened earlier. So here's the here's the EDSL approach, right? Where we have all sorts of things that impersonate strings and integers and actually record. And then we need to have operations on these impersonations of these things. So we create all sorts of extension methods. In Scala 2, these are implicit classes typically. And then, of course, when we actually try and use primitives in these things, we also need to lift the primitives to some kind of impersonation, typically involving implicit operations. And here's one possible way to do that. One possible way to do that that's not really good. And to be fair, right, this is slick. To be fair, when Stefan Zeiger wrote this, he was working with limitations that existed in Scala 2.8. And that's where the design of this comes from. So sort of not ideal, but understandable why this is happening. The thing to understand is, right, we have these representations in this sort of data structure that exists in Slick, the Q, E, and C. The most important are these representations of things. And these representations ultimately give life to the ability to do things like comparison operators and all sorts of stuff like this. And because ultimately these are impersonations of the data types of the table columns. Well, here's an example of an EDSL that's done right. Right? This is incredibly pleasant. This is very, very composable, and you can do queries on this. Right? This is a very nice way to do EDSLs. And if you can guess what this is ZOSQL, and it's a very nice library that essentially can compose different pieces of tables into different operations. So EDSLs can be done right. And this is an example of an EDSL done very, very well. The thing about EDSLs, and the thing that no EDSL can do, is that EDSLs do not have access to the compiler. They are not able to actually see what the compiler sees. And so they cannot see the direct representation of what that is, this thing here. A macro system, however, does. A macro system sees what a compiler sees. It knows what the compiler knows. So it doesn't need impersonations of strings and integers and all sorts of stuff like that. It doesn't need to do all of these things. It just sees that code. Now, okay, what is that code? What is it that the compiler actually sees, right? Here's how a macro is defined. And this expression here is this thingy here. Well, what is it, right? Is it the code that you wrote? Is it ASCII, right? Well, it's not that, because that's too early to be useful. Well, is it the bytecode, right? That's a little bit too late to be useful. So before the ASCII, after the ASCII and before the bytecode, there is this thing, a parse tree or a syntax tree that the compiler has built up to actually be able to understand the code that you wrote. And that's the compiler's syntax tree. Now, in Scala 3, you actually have an abstraction of the syntax tree, which is sort of a slightly more generalized syntax tree that's portable across Scala compilers, which is very, very cool. And so it's sort of like a syntax tree API layer called Tasty. And this is what we use inside of our Qdsl, our macro system, to be able to learn what's going on in this expression and ultimately turn it into SQL or do something else with it. So here's what that actually looks like. Here is the Tasty syntax tree, or a rough approximation of it. So essentially, right, we have this identifier. We select something from the identifier, right? We select the name field from the identifier P. And then from the result of that, we select the equal method, right? Recall that Scala does not have operators. Everything is a method. So this is actually a method. And then what we do is we apply the argument Joe to that equal method. And that's what the whole expression is. So, okay, here's this expression. Now, how do we do anything useful with it? Well, we write some kind of parser. Now, I'm parsing this tree directly using matching combinators. There are several different ways to do it. There's a slightly more higher level way to do this called quoted matching that, for purposes of this presentation, I will not be able to get into. But there are a couple of different ways of pulling this thing apart. And once you have that, well, what do you do with it? Well, you typically want to translate the expression that you see into some kind of form that's more useful to you. And with EDSLs, you kind of have the same thing. You have some kind of DSL represented as a bunch of different nested expressions, and you need to transform that into something that you can do some useful work with. Typically, that will look like yet another syntax tree or yet another ADT of some kind. So in this case, we're creating a simple abstract syntax tree, which is an ADT that can represent more directly what we want to like encode in our expression language. And then, right, we build up a parser and then we run it. Now, here's what happens. Here's the result, right? We had something that looks like this, and now what we have is this thing here, right? This looks a lot more like p.name equal to Joe. We can kind of understand this. And then once we have a representation that looks like this, well, it's pretty darn easy to transpile into a string like this, or into an API call, or into some other simplified language. It's pretty easy to do that once we have a representation that looks like this. So, right, that's what Quill does, right? This really look into function, we call that quote. Except for that, you know, quote does more things. There are more things we expect inside of there, right? We can't just have this P thing here because it would be a dangling identifier. So it needs to come from somewhere, a lambda expression or whatever it is. So this is Quill in essence. But that's not where the story ends. That's actually where the story just starts, because there are many, many, many other things that we can do with this approach. For example, let's say that we want to have an API that's more ergonomic than for comprehensions, right? There are potentially other things we need to do inside of for comprehensions, like declare variables and a whole bunch of other things. And especially when you want to mix in higher level operators and conditionals and other things inside of here, this can become unwieldy. So what if we want something that looks much more flat, like this? And we just want some kind of thing to look into that and to be able to resynthesize the actual for comprehension. And by the way, we want to be able to abstract over effect types. That would be pretty cool. Well, as a matter of fact, that exists. Flavio created it, called Monadless, which is a really neat library that can essentially lift flat expressions into essentially effectful for comprehensions. And potentially we can even do something more low level than an effect. Like potentially we could just take these things and directly execute them on fibers. So this loom kind of changes the potential of what we can do with stuff like this. So that is another very cool use case for metaprogramming. And hopefully, it's a pleasure to have Flavio on our panel, and definitely going to ask some questions about this, as well as some of the optimization work that he's done on the JVM. So sit tight, we're going to get there. Let's talk about a different problem, though. Let's talk about a different issue. Corporations have business logic. And sort of the larger the corporation, the more business logic they have. And I think it goes up by some nonlinear curve. I don't know exactly what the polynomial on that would be, but it's more than just linear. Large corporations can have hundreds of thousands, millions of pieces of business logic, and these things, they don't live in any central place. They're kind of embedded in things throughout the code base. So, imagine you have some kind of CRUD application where you'll have the UI that does some form validation, and you'll have some business logic that lives in there. And then you'll have the middle tier written in Scala or Java or something else. And you'll have some business logic embedded in services there. And then you'll have some SQL code that, for performance reasons, we need to have business logic embedded there. And so we have snippets of business logic embedded all throughout a code base. So there's no central place to manage them. They're just sort of dispersed. And the problem is that when businesses want to convert technologies, it carries an immense risk, because it's actually really hard to know in a particular code base where all the tiny little snippets of business logic are going to be. And if there are hundreds of thousands of these, when you actually need to do a migration, the chances that you'll get something wrong is extremely high, especially given the fact that the people that they hire to do migrations are typically not the people that have written the logic in the first place, right? And this is the way that sometimes, you know, people reason, which is that, oh, you know, we can get sort of like the B team to do the migration from one code base into another code base because it's just translating code to some other code. And then what happens is that people don't actually know what the business logic does, and they make a mistake or make an assumption that they shouldn't be making. And then millions of dollars can potentially be lost as a result of that. And so, you know, something as simple as migrating from SQL Server to Postgres to Redshift or something like that, just because most SQL dialects of most major database vendors aren't really even ANSI compliant, if being ANSI compliant is like actually a thing that exists. But anyway, it's even that, something as simple as that can potentially have millions of dollars of risk. So, okay, fine. If you write all of this in Quill, we support all these different vendors and their different sorts of personalities. So long as you're staying within the landscape of what Quill does, you don't carry risk of doing that because, you know, this is written in Scala and it becomes transformed into this abstract syntax tree. And then from this abstract syntax tree, we can synthesize into whatever SQL dialect we need to go to, right? So you don't have to worry, right? This is when this is represented as this, we have some guarantees about it being able to cross compile. Now, okay, fine. What if we want to synthesize it in a different language? What if we want to move it to some non-SQL language? What if we want to, you know, move it to Scala or Java or Go or anything else? What if we want to synthesize this logic in a completely different kind of language? So then you start thinking about it. Wouldn't it be nice, if you're a large company, to have a dictionary or sort of an index of business logic? And that I guess a dictionary is a better term. That dictionary of business logic functions you can then take and then you can transpile in all sorts of different languages. And you can find a way to embed them in a code base that it has a back reference to the dictionary. There are ways to do that. So essentially, you can immensely reduce the risk of migrating between one language and another. Well, as it turns out, the Morgan Stanley folks were thinking about this. And this is actually very, very impressive because most corporations do not think on this high a level. So this is kudos to Morgan Stanley for actually thinking on this level. And then what they came up with essentially was with a system called Morpher. And Damian Reeves is going to be joining us for our panel later today, and he's going to be talking about Morpher. And this is super exciting because this has the potential to be a game changer for how business logic is stored and encoded. This is immensely valuable, potentially. And if you have personally ever had to migrate from one code base into another and just if you've actually had to go through the pain of ever doing that, you'll immediately understand how something like this can make your life a lot better. Now, here's the question. To encode business logic, you need some minimal set of functionality from a language that can cross that can transpile to other languages. What, right? That's the most important thing. How do you get at that minimal amount of functionality that is good enough to compose a very wide array of business logics, but is still restrictive enough that you can't do things that are crazy, like side effects? Well, as it turns out, functional programming is part of that equation, but there are a few other interesting things, like the ability to be able to define data types in some consistent way, the ability to be able to restrict what can be done to things of those data type, a couple of other things. So what they've chosen is Elm. And Elm is this really, really neat language that essentially lets you define business logic on this sort of abstracted level. And then what you can do from there is, this is the syntax tree. This is actually the Elm syntax tree. This is, it's got more features to it than the Quill syntax tree, obviously. It's substantially more powerful, but you can convert between the two reasonably. So one of the interesting things is we can actually get Quill or Quill-like quoted DSL clauses to transpile into this kind of AST, or intermediate representation, as they call it, which you can then use to essentially synthesize and code generate a whole bunch of different things. Now, there are a bunch of different companies. This is Goldman Sachs, and their Legend project is involved in this. Microsoft has written a language called Bosky that has some very interesting ways of verifying compile time code. This is part of the FinOS financial open source initiative. So it's very, very exciting to think about the future of how business logic can be encoded. So there's yet another case in which you can use metaprogramming to be able to guarantee. Actually, let me mention in particular, for the Scala use case, what's very exciting about being able to use QDSLs and quoted expressions is that you can use the macro system to actually limit what can happen inside of here. That's the most important thing, right? That's why this system was created in Elm, to essentially restrict all of the side effects. And so you can do that with quoted DSLs. Like if somebody does system.out.println or system.getProperty or file.read, right? What do? We just say unrecognized operation, and we say that right there during the compiler. You press that compile button and it says, nope, we cannot encode this into a Morpher intermediate representation because you have things in here that cannot be done. So this is super, super exciting. And I am super glad to have Damien join us and talk about this. Now, here's a question that we need to ask. If macros are so cool, if metaprogramming is so cool, why hasn't the world sort of heard about it yet? Why aren't they more famous? Well, the problem is that in Scala 2, they're kind of dark. They're very, very gritty. So in Quill, the way that we generate the query, well, let's start with the problem statement, right? If you ever put this thing into Ammonite and actually looked at the return type, this is roughly speaking what you'll see. This abstract syntax tree for this query, the Quill abstract syntax tree, is this. Now, okay, fine. Now, let's say we define this Q variable with that syntax tree that I just showed you and use it in another quoted clause. Okay, how do we know what syntax tree this Q variable up here was, right? How do we know that? Recall that the compiler doesn't know what the value of this variable is, right? The compiler just sees a value. It sees an identifier Q. It doesn't know what this is, right? It doesn't know that, oh, eventually during runtime, you're going to execute this expression, and into this expression, you're gonna be writing a particular value. The compiler doesn't know that, right? Because that's runtime. That hasn't happened yet. So how do we deal with this? How do we figure it out? How do we connect the dots between this expression here and the thing that it actually needs to plug in, right? We're using this. We're saying this is a query of people, and we want to filter by the Joes. But how do we know that this is a query of people? All we see is identifier of Q, and this can be arbitrarily complex. This could have some other filters and some other clauses, right? This could be pre-filtered to a query of people over the age of 21 or whatever it is. There are other things that can be here. How do we know what this thing is? So, and this is a brilliant trick that Flavio figured out, and that sort of metaprogramming people in Scala 2 have figured out. The brilliant trick is that this is a refined type. So what gets returned from this quoted clause is not actually an object quoted of entity query of person. What gets returned is a refined type that has these things on it. And because it's a refined type, we can add annotations to the fields of it as well. And Java annotations have the interesting property that we can actually put syntax trees into them. So this thing we can put inside of here. And just an admission, there are certain important details here that I'm not mentioning. This needs to go through a certain sort of lifting / serialization process in order for this to actually be possible. It's like a hardening process, if you will. I'm not going to go into that. That's the topic for potentially another talk. But roughly speaking, in a hand-waving sense, that's what we're doing. We're splicing this tree onto here. And this sort of brilliant trick is the way that we actually get this expression here into there. When we look up this variable and we know that it's a refined type, we then go look at this annotation, which exists on the type level, and the compiler knows that we could get at it. And so from the type level, because this is a refined type, we look up that expression here and then splice it into the syntax tree that we get from analyzing this statement. So voila, right? We splice this thing here inside of this thing here. And that's how we know, from essentially adding these Java annotations to refined types. Now we continue this process, and then there's a ladder quoted AST, and we continue to put the syntax tree onto that, right? We splice the whole thing into there. And then eventually this goes into a .run function, and we pass in the variable that this thing is eventually assigned to. And again, it takes this expression here from this annotation, and then it returns, or it takes this expression, does a bunch of transformations, and then returns this query, all during compile time, because of these annotations that we can look up on these refined types. Now, this is very, very cool. This is a very cool way of doing it, but it's also a little brittle. Because say that we do something as simple as adding a type onto there, or a type annotation. Now, sorry, the word annotation itself is extremely overloaded. This is a Java annotation. This is also called an annotation. It's called a type annotation. So when you hear the word type annotation, it's this. When you hear the word annotation, it's this. And I'm sorry about that. It's just the terms are overloaded. But anyhow, if we add this type here, then essentially that blows away all of the refined type information that we have, right? Because the refined type is on this value. So if we give it an actual type, it gets blown away. It's called widening. And whoops, we can't generate a compile time query anymore. Our query is now dynamic. We can give you a dynamic query. We can give you a query during runtime, but we just can't give you one during compile time. So that is unfortunate. Now for Scala 3, this changes in an incredible way. In Scala 3, we have this thing called inline, or inline def, most particularly. What inline def does is that normally this is what the type would be. In fact, it would even be without this AST thing, it would just be this. What inline def does is that the result of this whole thing is stored in this variable. So in here is stored the entire tree, the entire syntax tree that comes out of this quote function is stored inside of here, which means that quoted no longer needs to be a refined type. Quoted can now just be a simple case class. And we can just analyze the tree that happens inside of here. And then based on that, well, it's the real thing, right? Like the real thing is there and we can just introspect it. And so when we use that thing, right, say that we use this Q variable, well, guess what? We just take the inside of this thing and we pull it out, right? Swap it into there. And then swap it into the next quoted block. And then once we're there, well, we run it. And the run function gets it. And we turn it into SQL. And because all of these successive trees that were stored have all been inline, we have access to all of the different trees. And so we just grab them one to the other, to the other, to the other, to the call site of the run function, and voila, SQL. No more need for refined types and storing things on Java annotations. And okay, what are some consequences? First of all, right, you have your type annotation here, right? You type it and you're just fine. That will not blow away the ability to do compile time query generation. But that's only the tip of the iceberg. What we can actually do is we can take this expression and pass it into a slew of different machinery. We can pass it into methods and other things and implicit resolving things and type classes and all sorts of stuff. And so long as the final output is also inline, well, guess what? We can give you a query. And this is a whole new landscape of capability that can now happen because of inline. Sort of inline, as I've said before, inline is to Scala 3 like implicit was to Scala 2. It opens up a new landscape of possibility. Hopefully it's a little more ergonomic than implicit was. I think it is. But in terms of the capabilities that it adds, it is absolutely immense. If you want to know examples of this, sorry, shameless plug. This is a video that I did about that, end of 2020 at Functional Scala 2020. So if you're interested, go ahead and watch it. But anyway, the answer to the question of, I think, why hasn't metaprogramming happened so powerfully yet is because Scala 2 metaprogramming is not a consumer technology. It requires some extremely specialized knowledge, and it's a difficult thing to do, versus Scala 3 metaprogramming is much more of a consumer kind of product. And there are different levels of consumer product, right? Like the prototypical consumer product is Spring, right? The Spring framework is a consumer product. But there are different levels of consumer product. There's prosumer, right? So for example, Zio is what you would call prosumer. So I think Scala 3 metaprogramming essentially is becoming a sort of to the high end of prosumer, sort of a prosumer technology. And the reason for that is because there are guardrails. Scala 2 metaprogramming has very, very few guardrails. It is extremely easy to shoot yourself in the foot. Scala 3 metaprogramming has some very, very important guardrails. Again, I do not have time to, in this talk, to go into that, but some extremely important guardrails that help you against doing things that just will fail in all sorts of unexpected ways. And so the usability of it was very much considered. Alternatively, some people will go as far as to say something like this, and there is a lot of truth to it. Scala 2 metaprogramming almost is like a black art, and Scala 3 metaprogramming is much more like science than it is like witchcraft. The same thing cannot be said of Scala 2 metaprogramming, unfortunately. So sort of this is the reason why I think that metaprogramming can now happen with Scala 3 in a very, very powerful way. Now, I'd like to talk about Quill Contexts. Talk a little bit about how it's improved in Scala 3, and also some interesting notes about the Quill Zio context as well. So here's a Quill context, right? Here's a plain old Quill context. And the thing that you need to understand is, well, we need to put a connection pool into it in order to be able to create it. Well, here's the thing, right? That essentially means we need to create this context variable, and we need to import stuff from it in order to be able to do quotation. Quotation comes from inside of here. This changes in Scala 3, by the way. We'll get to that soon. But we need to import this variable. And so the question then becomes, wait a minute. If we want to have, let's say, an intermediate module here, and then we want some other module to use the queries that we defined in an intermediate module, how do we do that? This is a path-dependent type. And path-dependent types, quotation is a path-dependent type. And I'll show you how that is later. But path-dependent types are notoriously difficult to abstract over. So how do we do this? Right? How do we actually have a context that inherits some queries that we created in a parent module? The simplest way to do it is like that, right? You can just pass the context in through different constructor parameters, right? Easy peasy. Well, no, it actually does not work, right? Because quoted is a refined type, it's path dependent. And so if you try and use this people variable here that you define in here, you will get a compile time error, because it actually says, wait a minute, this thingy here is not what this thingy here is, because the quotation is a path-dependent type, and it is essentially, right, this is a private variable, right? Once we've put it into the constructor, it essentially becomes the equivalent of a private variable. But wait a minute, because quotation is a path-dependent type, and the private variable is on the path of the dependent type, it's like you're exposing this private variable. So this is a very, very big pain point. Now, quite notably is that in Scala 3, because quoted is a case class, in Scala 3, this pattern is perfectly fine, because quotation isn't a refined type, it's just a case class. So you can just import things that you've had in other contexts and they compile just fine. So we don't even have this problem in the first place in Scala 3, which is very, very cool, I think. But this is sort of the chief issue of modularizing Quill queries that we need to worry about in Scala 2. Well, how do we solve this? Well, typically the way we solve this is by putting this variable here. Now, oh, sorry, by the way, there are ways to actually like solve this thing. Like you can make this thing into a value. And if you do, all sorts of other problems happen. Eventually, because Quotation has some other path-dependent types and encoders and other things, there are other things later that will fail if you try and work around it that way. Just FYI, if you're sort of thinking about that already, oh, we can just make this into a public variable. Other things will fail later once you start down that path. Now, okay, the way that we typically solve this in Scala 2 is by making context a variable that actually lives inside your module. Variable. So that way, what we can essentially do is we can just layer our modules one on top of another, sort of like that. Now, this is kind of tricky, and eventually it leads to things that look like the cake pattern. Maybe yes, maybe no. There are all sorts of problems with this. We can try a different approach, which is actually defining our queries on a context. And by the way, I'm using the Scala 3 optional white space syntax here, but similar code exists in Scala 2, so you can just pretend that we've reformatted this. So what we can do, sort of the alternative, is to create our context and have some self types and directly declare our different queries on the context. So, and that we could do that and then pass around our context, but this also leads to cake pattern. And so what will eventually happen is, okay, fine, we just layer all these different pieces of functionality. And when we declare our context and we append all the modules to it and then run things, well, as you start to have more and more and more kinds of things that this can do, and more kinds of schemas and query types that this thing has, and essentially when corporate code turns into reality in this form, again, the cake pattern becomes nasty. And we have dozens and dozens of mix-ins that need to happen in this kind of way. So how do we solve that? Well, with Zio, we don't have this problem in the first place. And this is why I've decided to design the Zio Quill context the way that it is. Because when you execute an actual query in Zio down here, when you actually execute something, well, that's when you pass in the connection pool or the connection. You don't pass in the connection pool when creating the context, which means the context can be a global static, which means that the path-dependent types on the quotation thingy are also global statics. So you just import this. You just import it into your module from the global namespace, or not, right? Whatever you need. They are static. This no longer has a problem of being this kind of path-dependent thing based on some variable that's difficult to pass around. No, it lives inside of modules that are ultimately static. Static in the sense that they're not like completely static to everything. They're still inside of other modules, right? But they exist in places that you can statically get from anywhere. You don't rely on having to reference some variable. And this is all because of the fact that Zio has this sort of parameter that allows you to specify an environment. And what's funny is that had I known that this was actually sort of such a good design decision, I probably would have designed the Monix Quill context differently. I would have used some kind of resource pattern or some kind of pattern like that, because by having to pass in the connection pool, you have to do a whole bunch of crazy things like use thread locals to store it if you need to keep it for other queries that need to happen to previous things where you need the same connection object. In particular, this is the transactional keyword that exists in Quill, and all sorts of crazy things. If you just have this approach, none of those problems even happen. So had I known this kind of design pattern, I would have designed all of the Quill contexts differently. And it's like Zio has informed me that this is the right way to do things. So, kudos to John and the creators of Zio. This is absolutely awesome. This is like Zio is teaching me how to functionally program correctly, and sort of, I know what resource patterns are. I know what resource monads are, and what reader monads are, but sort of to someone that's not using this in their work on a daily basis, it just didn't occur to me. Oh, if your context is a variable that's hard to pass around, it has path-dependent types, then the best thing to use is a resource or a reader monad. Like, it didn't occur to me at all. The fact that Zio puts it all in right there, and you can see it right there, these are the different kinds of things that you will want to do at the core of your logic. I think it's absolutely an amazing design choice that John made in doing this. So anyhow, so this is the Zio context. You don't have this problem of having to have a connection pool to create the context, hence the context being this crazy path-dependent type. You don't have this problem in the first place with the Zio context. A similar kind of story with the Cassandra Zio context. Something that I do need to mention also, by the way, in anticipation of Zio 2.0, which will get rid of the blocking keyword, I am very soon going to commit a change that will essentially get rid of this sort of funky little Q connection thing, and it will just be has connection. And this is java.javax.sql.connection, and it's has of this. So this should simplify. This should substantially simplify. The logic of how these contexts are injected. And also there'll be a keyword as DAO, and that will change it. That will change the Zio dependency parameter from has of connection to has of data source of closable. And if you provide a data source in there like that, then what this will do is that when you actually run the query, right inside, it'll pull out a connection from the data source and return it right back. That's kind of like the data access object DAO pattern, right? You have a query, pull out a connection, put it back. And this will work with transactional correctly as well, right? It'll take it out for the entire transactional thingy and then put it back at the end. So that'll actually work exactly like the Doobie transactor does, in terms of that whole flow. So this is very, very cool. This dependency parameter thing that's right into here. And so we can use this thing without having to do all sorts of internal management of connections in the Quill context, and this will just run on the regular. Well, it already does. It already runs on the regular Zio blocking pool, except that it won't have the sort of the blocking keyword in there, because they're going to get rid of that in Zio 2.0. And on the panel, I'll ask Adam to talk a little bit about that and the reasoning behind that and some other interesting changes and thoughts. So, okay, let's talk about Scala 3 for a second. Well, in Scala 3, what I decided to do was I decided to make quotation global. But what does that mean? Well, that means that quotation no longer comes from the context variable. Quotation lives inside of io.getQuill now. So that has a couple of interesting implications. The first being that you actually don't need a context to make quoted things. However, you do need a context, and sorry, this is actually a mistake. Run is not possible to do in here. You do need a context to be able to run queries, and you also need a context in order to be able to lift. The reason that you need a context to be able to lift external variables is, well, you can imagine lift works something like this. It doesn't. Lift is a macro function, and it has some more complicated functionality, but you can imagine that it works something like this, where in the lift function, we directly take the thing that you passed inside, and we put it into the current connection that the context has, and then we actually, in the prepared statement, we directly set the slot for that variable to be that value. So we're essentially, when you do lift, we directly grab the JDBC layer and set the variable. And by the way, if it's Cassandra, we're not using the JDBC layer, we're using the Cassandra prepared statement. Similar kind of logic. Whatever underlying implementation it is, we directly grab that and set the value into it, which is why, of course, it cannot be in the global namespace, right? In order to be able to have an implementation specific logic inside of lifting, well, we actually need to know what kind of database you're using. So we can't make it global. However, oh, by the way, we actually summon a string encoder. There's some more advanced logic in here. So this is a closer representation of reality, slightly closer representation. However, what we've introduced, and something to experiment with, is we've introduced the concept of lazy lifting. What lazy lifting essentially does is it stages the lift into this sort of intermediate form, and only when a context is introduced do we actually do the injection. And in fact, only at the run site. Now, sorry, this slide is also wrong. We need to actually import a context before we run it, but that is the only thing. Lazy lifts can happen from the global namespace. You do not need to import a context into your code to be able to do a lazy lift. And so the end result of all of this is that you can define queries, many different kinds of queries, in places, all sorts of places throughout your code base, and you do not have to rely on having context there. This is really neat. We do lazy lifts in order for you to be able to actually lift things inside of contexts where you don't need to, or excuse me, in sort of places in your code base where you don't want to define the context. Now, there is a limitation here, unfortunately. Lazy lifts do not work with dynamic queries. That's why I didn't make all lifts lazy, right? If it's so cool, make all lifts lazy. I cannot do that because they do not work for dynamic queries. So you have to watch out for that. Eventually, I might be able to make them work with dynamic queries. The Izumi folks have this interesting serializable type tag that I might be able to transfer that type information, which is what I need and why I can't do it right now, but there's some other issues associated with that. So there is the potential that someday in the future this will be there. It is not there right now, unfortunately. To do lazy lifts, your queries need to be static. Now, finally, let's talk a little bit about migration, about sort of migration from Scala 2 to Scala 3. Now, okay, here's our typical kind of Scala 2 context. We're running some queries, we're inserting some batch stuff, we're importing stuff. Now, here's the thing to note, right? Quotation comes from this import in Scala 2. It does not come from this. And so a lot of the time, what a lot of code bases have is they don't have a star import on this. And that's understandable, fine, for performance reasons or whatever other compile time reasons you might not want to have a star import. Well, you might want to add it to Scala 3. Because, and typically you'll only have to like import io.getquill.query and then maybe one other thing from that namespace. And so that isn't really used all that much in Scala 2. In Scala 3, quotation comes from here. So you need to import this and a bunch of stuff inside of here. So I would say start with the star import and then whittle it down to the imports that you actually need if you don't want to have a star import. Otherwise, just use the star import. Now, okay, this Scala 2 context gives us compile time queries. Now, let's say we switch it over to Scala 3. Your code should still compile. It should still run, only the queries will be dynamic because we no longer use refined types. So what do? Right? Instead, we use inline. So you convert your variables to inline and you get back your compile time queries. Hopefully, at some point in the future, we will also have a Scala fixer rule that does this if somebody helps me with Scala fix, but this should be doable. So now there's another pattern where people have an abstract context on some kind of trait and then layer on the real one later, but people like run this thing inside of that. That's a problem because we don't know what this context is yet. The way that we do this in Scala 2 is that we assume that it's a very sort of abstracted context. We have some assumptions in here. This will work, but it does not work in Scala 3. So you need a real context, not an abstract context. But I should probably improve this error statement. It says that you cannot get idiom because the dialect is not defined. I'll try to improve this particular warning, but if you see this, then that's why it is, because you have an abstract context that is not yet defined the dialect. So, okay, how do we, right, what do we do about this? Well, you've got to move your run function down to the level of the context where you actually have the real thing. Now, you need to do one other thing. This will still be a problem because this variable here is still this, right? You actually haven't told the compiler that this is actually this. So when it tries to do these things, if you have lifts inside of here, potentially, it will say, oh, we can't, or not even, sorry, not lifts. Lifts is encoders. This is decoders, right? It cannot decode it into a person object, right? This is a person object here, right? That's what we had, because the decoder for the person object also needs to get imported from the context. But guess what? Up here, or actually down here, the context is still abstract. You actually need to take this variable and properly type it to the full thing, and then you'll have your query. Now, one other interesting pattern that I've seen, I did not know about this at all. This is something that Daniela Segfora, I think that's how you pronounce her last name. Please pardon me if I butchered that. But one interesting pattern that she showed me was that you can actually embed logic inside of a function before you return a quotation. This is a very interesting kind of pattern. I have not thought about this. You can't really do this. You can't really do this in Scala 3. Well, you can, but sort of your query in Scala 3 will be dynamic. So it'll turn dynamic with Scala 3. It should still compile, should still be fine. It'll just be dynamic. Now, if you want it to be static, right, and you turn this into inline def, well, it'll still be dynamic, right? Just an inline def, if you don't have any other things inside this function, right? It'll immediately turn into a static query. But if you have other things in this function, well, guess what? It'll still be dynamic, because the quoted context, or the run function that tries to introspect this, cannot sort of do the beta reduction and actually like plug this thing into this thing and this thing, into this thing here. It cannot do the whole process. Again, I might be able to change that at some point, but that is a limitation that we have now. In order to fix this, basically what you've got to do, and by the way, if you try and make this internal variable also inline def, compiler will give you an error because nested inline methods are not supported. They might be sometime in the future, but they're not supported now. This is a limitation of the Scala 3 compiler. So you've got to move it out. Move it out into the context above, and make sure that every single quotation is given its own inline and its own inline def, and you should be fine. Now, okay, we're just about done and ready to switch over to our panel. Hope I haven't taken too much time. So we talked about how metaprogramming is cool and can do a lot more things with Scala 3, how Quill is more ergonomic with Scala 3 as well as with Zio. And we talked about migration and how you can do migration without too much pain. And thank you. Huge thanks to Zyverge for throwing this event. Thank you, Sandra. Thank you, Adam. Thank you, Kit. Thank you, John, so much for putting this together. Again, the alternative would be me sipping vodka on my couch. So I'm so happy to be able to be sharing this with you guys. I've also got a shout out. Thank you to the EPFL folks. Thank you, Agalos. Thank you, Nicola. Thank you, Lee, for helping me out throughout like 10 different Dotty versions and migrating my code base from one to another to another to another. And thank you, panelists. Thank you, Flavio. Thank you, Damien. Thank you, Adam. Thank you, Kit. Thank you, Prakar, for being willing to join us for the panel. So that's it. If you're interested in having a look at Proto-Quill, that's Proto-Quill is Scala 3 Quill. There it is. And voila, let's move on to the panel.
Awesome. Well, thank you so much. That was an incredible presentation. I think a great overview at the beginning of the embedded versus quoted DSLs and how to think about that, and then overview of some of the features. So really fantastic. And yeah, it's just great to be able to celebrate you with you a little bit, because I feel like when we do open source, overall, it's like a real privilege, but sometimes when it's late at night and we're like pulling our hair out over some crazy bug, there's frustration too. And I think you probably deal with more of that than a lot of us, with kind of dealing with all these databases and their weirdness and trying to kind of take that and abstract over it and give us a nice way to work with it. So it's great to be able to kind of celebrate with you.
Thank you. Thank you. All right.
How would you like to get started here? You want to, I think you already set up a couple of panelists. You want to maybe do like a little bit of introduction, and then you want to start us off?
Yeah, sure. Let's do some introductions. Flavio, let me introduce you first. Flavio wrote Quill. Flavio wrote the original Quill for Scala 2, and it was an immense accomplishment. The sort of the design, the understanding, everything that it took in order to do was an immense thing. And sort of Flavio is somewhat of a prodigy. He not only did Quill, but he did monadless, and he's working on JVM optimizations, some incredibly interesting low-level JVM optimizations that he's doing from Twitter that we'll ask him about in a minute. And it's a pleasure to have him here with us. Damien works with me at Capital One now, formerly Morgan Stanley. It is wonderful to be working with you, Damien. It's been so far, it's been a blast, and so Damien is a distinguished engineer at Morgan Stanley, and it's really awesome that that he's here to share to share some of the motivations of Morpher with us. So thank you, Damien, for coming on. Adam, thank you. Thank you for being here. Everyone knows who you are. And thank you for coming on. Is Kit here?
I think he is stuck in another meeting right now, so hopefully
Kit is stuck in another meeting. All right. Hopefully he'll come on, and I've got some questions for him too. Prakar, thank you for coming on and joining this panel. Prakar led a group of Drexel students to help me with the Scala 3 or Proto-Quill parser, because there's quite a bit of work to be done there. And so I had the pleasure of training Prakar and some Drexel computer science students in Scala 3, as well as metaprogramming at the same time. Lots of interesting learnings there, and a sort of a full perspective of how do you actually convey the understanding of all of this, is sort of all the way through. So gonna ask you some questions along those lines. So let's start with Flavio. So tell us a little bit about why you wrote monadlists and some of the motivations behind that.
Yeah, so can you hear me?
Yeah.
Okay, cool. Yeah, so monadlists was like this interesting experiments I did a few years ago. So you have like these kind of solutions that are like async await solutions that are normally only for async computations. So you have like the Scala async, or you have like in JavaScript and etc. And the idea of monadless is basically generalize that for any monads, right? So you can have like something like async awaits, but that gets translated to the monadic composition below it. So it's very similar to, if you look at for comprehension, it's really syntactic sugar for calling map and flat map. And monadless basically does that for this like block of lift and unlift calls. And I feel like it's something, it takes like a lot of the complexity that people see when they have to write codes in Scala. I see like people doing like future computations or doing like ZIO or anything like that. And sometimes it's really hard to express something that would be very simple with like without a monad, without like asynchronicity and etc. So monadless tries to bring that back a little. And yeah, I think it's an interesting experiment. There's, I think, some developments in Scala 3 around that area, but I'm not really following to know where it is.
So here's a question.
Mm-hmm.
Do you think that monadless can actually go to, let's say that for monadless we decided maybe, with Loom, we decide we're not even going to have an effect type at all, right? We'll just get a scheduler to directly execute this stuff. Would this be a way to potentially get around the megamorphic inlining limitation?
Yeah, so I think in terms of Loom, it's a great tool, but it's currently focused more on asynchronous computations, right? And when you look at monadic computations and the way that you can manage them and do transformations and apply all like the great things that we do with like ZIO or cats or any other monads, it's not really at that level of power, right? So I think it's very interesting, and I think it's something that should replace the necessity of monads for asynchronous computations. But I'm not sure if it's going to be something that can basically replace everything that we are doing, like something like monadless or even monadic APIs and etc. Because you can get more power from these kind of APIs. It's like having a custom runtime, right, for the execution of computations, and that's something that Loom doesn't really provide.
Okay. Tell us a little bit about some of the optimization work, specifically around JVM optimization that you've done for Twitter.
Yeah, so we have like, we use futures. So we are not really pure. We don't do zero or something like that. Most of our code base is using futures. And there's like a few issues with that. So future being eager, like being strict, it's already running, right? So you have to have some protection around like adding continuations to the future being fulfilled in parallel. So you have like some complexity and overheads because of the things that you have to do to make it thread safe, right? And an interesting optimization I did at Twitter was virtualizing compare and swap calls. So we do the synchronization of the future states through compare and swap operations. And then like there was an issue in Growl, like if you have like a future that say you do future.map.map.map, you have like those two intermediate futures that are just like really something that doesn't escape the methods, is not going to be executed and used by different threads. So you don't really need the compare and swap there. These are like virtual futures that Growl detects as just like something transient. And what I did was basically make Growl understand that that was like a transient future. So you don't need to really do the compare and swap. And that way, like these like transient futures don't even need to be allocated. So that was like a large optimization that we got there as well. And there's like other issues like when you are using monadic APIs, your code becomes highly dynamic because you're running against this runtime that is like this monadic runtime, API runtime. And that makes like inlining more difficult. It makes it do more invoke interface calls that are more expensive. And there's like a few things that I've done around that area as well.
So in terms of specifically sort of so let me actually give a little bit of background. Monadic API calls, because they use lambdas inside, every single lambda in the universe is an implementation of essentially function one. And because function one has a gazillion implementations, inlining the code, which is a hugely effective optimization, is really hard to do. And so that's the problem. It's called the megamorphic inlining problem. So do you think that we'll be able to solve this problem sort of one day? Or what are your thoughts on that?
Yeah, I think it's a hard problem. I have a few ideas on follow-ups I can do, especially around more optimized caching of the target methods. But in general, it's a problem that's going to be always there. We can just attenuate the effects of that. There's like some things that we've done to try to avoid it. So for instance, we do like use a lot of arrows in our code to help with that, because we can basically create the arrows and we can have like a complete view of the computation without having like things that are not introspectable, like a flat map and etc. You can look at the whole computation, and that way we can apply optimizations in a way that avoid some of these issues. But it's always going to be this problem. It's really about like executing computations on top of an interpreted runtime that is the monadic runtime behind it.
Now, if you have a lazy future implementation that returns some kind of data structure once all of those calls are done, and then you execute on that data structure, and I as far as I understand, Zio does some of that in when you're building up your values, things like that, could they potentially also?
That's what we do with arrows. So you compose, instead of having like working on values, actual instances, you work on arrows from A to B. And then you have like lots of combinators that allow you to express things that you would do with like flat map and etc. And that way we can have like something that's static. We have like this bunch of functions we need to invoke, and we can emit codes in a way that's that has better performance. And that's something that we already do in a library called Stitch that we have at Twitter. It's a way of like patching requests to other services. So you do like write like single key code, like you were dealing with a single value, but under the hood, it's going to batch requests to other services. It's similar to Haxel from Facebook. And we do like use arrows to basically express computations once, save it in an arrow that's optimized, and then we can execute it with a better performance. But
Okay.
And for instance, like inline in Scala 3 as a performance optimization in general, it's not really good. Like it's better to let the just-time compiler decide when things should be inlined because it has more information. But for metaprogramming, like for Quill, it's very interesting, but it's also interesting for this kind of like staging of computations, right? So you could have like an arrow API that stages the computation to be executed with a better performance, and inline could be an important tool for doing that, for instance.
Interesting. So, can I expect to see an arrow library that that you've authored that uses inline?
Could be. Let's see.
Okay. I was actually going to ask if you can come back and do some work for Quill rewriting the dynamic query API, but that's a little more interesting.
Yeah.
Okay. Very cool. Thank you for joining us. Damien, let me ask you a couple of questions. Why don't you tell us a little bit about Morpher and why you decided to start doing this, why you decided to get involved, and what are some of the interesting things it can do?
Yeah. So Morpher definitely was not my idea. I kind of joined a great team that had already started, and I like how you talked about the journey of the embedded DSL, and that's where they started. They started with an embedded Scala DSL to model business logic and to try to capture information for this business logic. And it just began to progress and go further and further along to where you see something that's really kind of based in language, in programming language theory somewhat. And the basic of Morpher, the centerpiece of Morpher is this intermediate representation in IR, you can call it an AST, that you kind of showed some pieces of that allows you to represent not just typical things like Avro and JSON schemas and things like that, tell you about the data model, but you also want to know about logic, and we wanted to be able to model logic in a way that you could survive versioning. I worked on event source systems where you want to do that playback, and one thing that was nice is to be able to say what happened at this point in time. So Morpher allows you to actually take not only your model, but your logic to write it down to an IR, and you can save that in a database. You can save it to an S3 bucket. You can do all sorts of interesting things. And so Morpher is this great thing, and it has a front end, the middle piece, which is the IR, and it has a back end. And part of what the team did is we switched from this embedded Scala DSL to where we use Elm that's compiled, and we compile that down to the Morpher IR, and you have multiple backends, and one such backend is to go to Scala 2.
Okay. Well, why don't you tell us a little bit about how Scala 3 can potentially make this a little cooler?
Yeah. Almost went into that. I wanted to give you a chance to
interject. Go ahead.
But yeah, exactly. So Scala 3 and inline, it's very interesting in that all that information, all that stuff that you talked about that's available, from that the quote and just being able to get the expression information, that's the exact sort of information we need to be able to build up the Morpher IR. And part of the reason we didn't do it before, we thought about it, is that Scala is on the JVM and you can't control things, right? So you have this big box where we could have mapped before, but we couldn't have stopped the developer from doing system.println or system.exit in the middle of what they're doing. So now, as I've picked your brain on this and we've kind of prototyped some of this, what's interesting is with inline, you can not only stop those operations, but you can give meaningful errors and do that metaprogramming to where you can now not only use Elm, which I understand there's some people who know Elm. We chose it because it's very constrained functional language that has no side effects, but you can make a subset of Scala that actually does this now with inline. And just so you know, we've thought about the same sort of thing with front ends for F#. There's some work going on where Microsoft is looking to do a front end for this in their research language named Bosky. So yeah, it shows a lot of potential.
Very cool. I think Adam even had the wonderful suggestion of, if you do something like a class cast inside of the quoted DSL, it makes an API call that registers the user who did that to take a functional programming course. That's like, I think, the cutting edge of the ergonomics that we can do.
Yes.
Please attend such and such a lecture. or
yeah,
we can track
it's great potential.
Yeah, you've attempted
and just to
go ahead.
And one of the other things that's interesting, if you ever worked with Elm, is it really has these like really meaningful and detailed error messages that tell you what you're doing wrong. So we've seen the potential where you can be like, you're doing a system.exit, you're doing system.println, here's why, and we can point to docs or whatever. So as much as it's funny, maybe we won't register them to a class, but you can point them to relevant documentation, or just help the user a little bit more along.
Right. I was actually thinking as far as to do like the whole Google thing. You attempted 4 class casts in the past 3 days. You've passed a particular threshold. But anyway, so this is actually very interesting because, as far as Avro and Protobuf and all that stuff, the vast majority of code generation, or at least schema generation stuff so far, has focused entirely on schemas. Essentially, it's focused entirely on data models. It has not focused at all on being able to generate logic. So, sort of, let me ask you this sort of question on that note. What do you say to all of us gray-haired, grizzled old developers that remember the UML days, and they remember the BI tooling days, where everybody said, "Oh, we can just connect one node to another with a code editor and generate code based on that." And oh, that's all failed. So you can't generate code. This can't possibly work. What do you say to all of us?
Well, first of all, and I hope you can hear me because my landscapers have perfect timing. I hear a lot of mowing in the background. But believe it or not, I was around in the days of UML. I remember internships in college where I worked for a company, and I was into rational rows, and I had to model everything in rational rows, and I do not want to go back to there. But what something like Morpher allows you to do is, as much as we have this code generation that happens, first of all, what Morpher aims to be is a set of tooling to allow you to use your models and your logic as data. So now you can do interesting things. Like, and this is some of the power I look at inline, and what can happen is that now we have these trees, we can take them and we can pull out data dictionaries for organizations that want to know what pieces of logic are referencing what areas, of their data. So you can get traceability all the way in. We've done things that we refer to as insight, where we've allowed users to have visualizations of their logic and use that for what if scenarios. We've modeled truth tables. So there's all that. So not only can you do code generation, but you can do so much more. You can do visualization, you can do all this stuff, and it's all the power of like types, trees, and it's 2021, everything's data. So even your code and your logic, your business logic is data. And one of the things that's great about this is right now we have things that go to Elm backends, but whatever your technology is, if you can write a backend that takes the centralized IR, you can map down to different technologies. We've had, as part of the Morpher thing, where we've it might not be the best thing for Zio conference or Zio meetup, but we have some Java developers who use Spring when there's been some things of like generating interfaces for Spring. Microsoft has another technology called Dapper, that allows you to kind of do like these API calls in a distributed fashion. And we've had some work in like looking how to use that. So all that because your data and your logic, because your models and your logic become data, there's a whole world of things that are, you know, possible.
Right, right. I think the key takeaway is we're not starting with diagrams. We're not starting with pictures. We're starting with code, and that code is data, and that code can be translated into other code. And based on that, through a series of translations into this intermediate representation, we can get some very powerful results.
Yeah, and if you want, you can do plant UML or plan ML or generate your UML from the code as it should be, not the other way around.
Yes. Start with the code. Yeah. Yeah. That's awesome. That's awesome. Thank you very much, Damian, for joining us. Adam. So what interesting things do I want to put you on the spot for? So let me say this, you know, definitely Quill has learned a lot from Zio. As far as I can tell, Zio has learned a thing or two from Quill as well. So do you want to talk a little bit about some of those things?
Yeah, definitely. So I think one of the things that you definitely showed us was some of the costs of having blocking be a service in the environment. So I think, you know, having the environment was something that Zio innovated on and was kind of a Zio 1.0 introduction. And so I think like a lot of things, like when you want to do something, part of what you do is you figure out, okay, how do we use this tool? And you end up finding some places it's good for, and you're like, wow, why did I have this before? And some place where you're like, yeah, maybe this actually wasn't the right tool for this. And blocking was, I think, always a little bit of like it never 100% fit, because part of the idea of these services was that you would have test implementations for them. And so any of the other standard services in the Zio environment, you had a test version of. You had the like console that lets you print the console, and you had the test console that like lets you print to this basically like in-memory buffer that you can like look at and you can see like, what did I print out, or you can feed data into it. And so there was a test implementation of each of these services, but there was never a test blocking service, because it never really made sense of like, what do you do to have a test blocking thread pool? Like, you want a blocking thread pool, you just have a blocking thread pool. I mean, you can certainly like verify properties about it, like it's unbounded or whatever, but you don't really have a test thread pool. And I think the thing that we saw particularly with Quill is, as you kind of integrated Zio Quill, is that you need blocking a lot, because you're dealing with all these databases that often are blocking, or even if they say they're not blocking, they actually are blocking somewhere. And so you need to have service, and like kind of passing that around from place to place created a decent amount of boilerplate. And so one of the things that we're doing in Zio 2.0 is we're basically just we're baking that blocking executor into the runtime. So the Zio runtime already had a concept of an executor, because we've got to run things somewhere. And we've now baked in a concept of, you have a normal executor for your core asynchronous tasks, and then you have a blocking executor as well. And you have operators that when you construct one, you get to specify what it is if you want to use a custom one. Otherwise, we've got a default one with reasonable settings for you, and you can provide your own if you want to. But that ends up just making things a lot nicer, because then for libraries like Quill, like you don't kind of have to pass this thing around, and it makes it a lot easier to work with the environment. As well as, I think one of the benefits that maybe has been less relevant for you, but I think other people are going to appreciate, is it's just less version specific code, because that blocking service was one that it only existed on the JVM before. So if you ended up doing something where you needed it, then you kind of needed platform specific code. And now that it's kind of baked in, it's just cross-platform. And you know, if you do it on JS, like it's just the same executor, which is the same one that always exists, because there's not that same concept there, but that's kind of invisible to the user. So if you are doing like a library where you want to support different platforms, or if you're doing something like a full stack app, just makes things easier for you that way.
Oh, so here's Kid. He's here right on time.
Yeah.
So one of the things that I was actually going to say was, in terms of Scala JS, something that's always been in the back of my mind is sort of Quill at least Quill SQL and those core modules already do compile down to Scala.js. I don't have the Proto-Quill modules compiled down to Scala.js, but I'm going to hopefully work on that soon. The next step is integrating some other higher level JS modules, like for example, Zio for Scala.js. And then the question is, so what? I don't even know what is some of the tooling available for SQL query stuff in front ends. Like, what is there? Are there APIs for that? Is it worth looking into that? Sort of what are some of your thoughts, Kit?
No. Sorry, no, it's not worth looking into. Well, from the front end, you probably don't want to make SQL queries from the client, but from Node, there are certainly SQL libraries that I've used and sort of have scarred me in the past. They're not terribly pleasant at all. Maybe there have been some advances in TypeScript, but none of which I've been blessed to experience.
What is SQLite? What is it there for? Like, what does it do?
SQLite, I mean, I believe, well, that's not necessarily JavaScript related, right? That's just the.
No, I mean, sort of. I think at some point the question was sort of, do we want to store table data in browser memory? Does it make sense to do that? I don't know that it does, but I've seen talks before where people have said, oh, we want to be able to store table stuff in browser data and query it later. And SQLite is like a supported format. Sort of, that was as far as that went.
Okay, yeah. So I guess cats are here as well. They just dove onto the table. Yeah. So I think SQLite is basically just it's just a file. So there's not a server. It's just a file that you can query, and it's in some special format, right? That I guess is going to be slightly faster than just deserializing a giant blob of JSON and looking that up. So there are lots of frameworks for the front end that I think get at this question, which is Apollo. Have you ever heard of Apollo?
Yes.
Okay. So that's not, I'm not sure, maybe that is using SQLite. I never actually looked under the hood, but basically it's kind of a GraphQL wrapper that can facilitate making GraphQL queries to some backend, but then it also, once it loads that into memory, you can continue to query it with GraphQL. So the difference between whether or not you're fetching your data from some backend server or a cached version that's in memory, you still get to access it with the GraphQL syntax. And same with like frameworks like Ember, which uses, I don't even know if JSON API is still possible, like a protocol that people care about outside of Ember. But it was like an attempted version of GraphQL, except just for JSON REST APIs. It was called JSON API, which is really non-Googleable, but very much did a similar thing where you could continue to make queries in some special query language against cache data and only invalidate that in certain instances, which I guess has nice benefits for like huge mega front-end apps where you're just dealing with queries all the time and don't want to, for simple pages, simple single-page apps, once you've loaded your data from the back end, you can just kind of keep it in some local state. But if you have a huge sprawling app that people keep open for a long period of time and you want to optimize queries and speeds to a ridiculous degree, maybe that's kind of the purpose for that, is to be able to continue to use all your queries, but query cache stuff.
Okay,
yeah.
Makes sense. Is the way, let me introduce Kit. I have not done that. So Kit also works with Adam, Damien, and I at Capital One, and Kit is a very, very, very powerful front-end whiz, and we are very, very thankful to be working with him.
Why are you disgracing my name? Why are you spreading this reputation around? I don't know of the front end. I know nothing of the front end.
Do not.
Yeah, you don't protest too much.
Yes. This is like if you know SBT, don't let other people know that you know SBT, because they'll ask you questions instead of going to Google. But anyway, Adam, I do have sort of let me ask you this sort of question. What do you say to all the gray-haired engineers out there that say, why do you need effect types? I've got my thread pool, I've got my fork join, I know exactly how to use that thing. And, you know, I can put things in, I can take things out. I know how to interact on that level. Why do I need effect types at all? What are these things useful for? What would you say to everyone that has that kind of thinking?
Yeah, so I think I would say if you're Doug Leah and you wrote Java Util concurrent, and that's why you got the gray hair, then like, yep, you can probably do your own thing without effect systems. I think you might probably still be more productive with them, but you can do your own thing. But if you're the rest of us, there are a lot of ways you can shoot yourself in the foot. There are a lot of like things you got to be careful of, and especially when you're trying to think about another domain, it's really nice to not have to think about that domain. I mean, even for myself, like if I'm going to go back and you ask me like implement some low-level Z-managed operator that's going to kind of describe like a managed resource with concurrency, like I'm going to have to really get in like that frame of mind. I'm going to have to be like, okay, let me think about like every possible point where interruption could be observed, and what do I want to happen there, and how do I want to handle that, and how do we make sure all this stuff is safe. And like I can do that, I can get in that frame of mind, but when I'm in that frame of mind, I'm probably not thinking about like my business problems or my domain or anything else. And it's really nice if someone's already thought about that and you can just use that, and you just are like, okay, got it, I got a resource, it's going to be automatically taken care of, I can just go on and do whatever I'm going to do. But yeah, if you feel like you're the expert on Java concurrency and you want to do it from the ground up, more power to you.
I think that you really hit the nail on the head there. Low-level code is something, it's something that you need to walk into. It's you know, it's a piece of instrumentation that sort of, you know, it's kind of like this big military vehicle that when you walk into that thing, you know, you got to be in a certain frame of mind. You can't like operate that thing with one hand and with another hand be doing levers on different kinds of sort of more higher level businessy stuff. It's sort of very hard to do that. You need to sort of fully embed your mind into that because of all the different, 50 different levers that you need to operate so that the thing won't blow up. So, we certainly have to spend some time there, but at some point in life, we need to walk out and be able to interact with the universe, and the universe where business dependencies and requirements change very, very quickly. And if we're still sort of embedded into these nitty-gritty details of, oh my gosh, I need to like redo the entire thing because the business requirement has changed, forgetting to keep track of one particular pointer is very, very easy to do, because sort of it's very hard to think on those two levels. And so that's actually why in a lot of code bases that are written with low-level code, there are memory leaks freaking all over the place, because it's not anybody who wrote that code, if they had the full time to completely focus on it, right, they would be able to write completely memory leakage free code. But the fact that people have to deal in multiple worlds at the same time, it makes it extremely difficult. So yeah, that's for the rest of us that need to do other things. Effect systems are there to make our lives tolerable. Kit, let me ask you this question, coming from the front end world. There's a similar kind of controversy over types there that has happened. So what do you say to all the Douglas Crockfordites and the holdouts that say types are an abomination, we don't need types? Who needs any of this stuff? We just have our embedded JSON objects, and we define some little functions on them, and we don't ever need to refactor them. It's actually Douglas Crockford said that. in a speech. He literally said that. He literally said, if you do JavaScript, you will never need to refactor. But anyway, what do you say to everyone espousing that point of view?
Well, that's kind of true in a way. If you do JavaScript, well, you're not going to refactor. That's maybe it's kind of a slightly almost there. You're just gonna burn down your code base or make a new one or build something on top of the other thing or just start again. Yeah, I mean, I can't speak for everyone, but I think I've mentioned before, I started out in Ruby on Rails and dynamic programming, and all I know is that I had this sort of this little substrate of constant anxiety, this little thrumming tinnitus in the background of my mind. The whole multiple years I coded in that style, something just felt off to me, and then I realized that yes, it's because I've sort of if I open up the activity monitor of my brain, like 80% of my memory, my RAM usage is being occupied by sort of tracking very simple type descriptions mentally and how the system fits together. And you just constantly have to, basically, you can't just make a change in one file. You have to basically first digest the entire code base before you can make a change. You have to follow manually in your text editor because, I mean, hopefully there's at least, even without types, IDEs have gotten slightly better where you can command click through the program, at least based on like identifiers. They're clever enough to do that, but the sort of just built-in glue and documentation and just knowing that like, yes, this plug fits into that socket instead of just kind of just wedging wires into whatever holes they may fit into. It just clarifies so much and lets you focus on the problem at hand, the hard problem at hand, and lets you like save your entire mental RAM allocation to loading up the context that's relevant to solving your problem without worrying about the entire system. Now, sometimes there are cases where you need to consider everything or lots of things, and it's still hard. But yeah, it's just kind of, it allows that basic idea of composition and of breaking problems into smaller problems. You just can never really do that without types, unless you're very, very consistent. I mean, it does force, like I have seen code bases written in dynamic languages like Elixir that are really well organized and really well documented, but it's still overwhelming. I still feel sort of frightened and I kind of still need to click everywhere around. But yeah, there are benefits to dynamic programming languages. I've talked about like active record in Rails before and certain things that you just wouldn't do in a type programming language. But yeah, I'm a fan of types.
It's funny actually, sort of the thought of needing to learn the entire application in order to make one tiny little change. I remember it takes me back to takes me back to some of my computer science exams where you have this test, which is this big multi-page algorithm. And then there's this one little box, which is fill in like four, 8 or 9 characters, like fill in the rest of this problem. And to be able to actually fill it in, you need to go through the entire 1.5 pages of algorithm and comprehend the whole thing just to be able to fill in this one tiny little box. Prakar can tell us in a minute if he's had one of those at Drexel. But I think yeah, that's essentially development without types can very quickly reduce to that. That's really cool. Thank you, Kit. Let's go on to Prakar for a few minutes and talk about learning metaprogramming, learning functional programming, some of those kinds of things. So, tell us about your experience learning Scala 3 and learning metaprogramming and learning functional programming and learning everything literally at the same time.
Also, hi Prakar and Flavio. It's nice to meet you.
Nice to meet you. Oh boy, that's a lot. Well, can you all hear me? First of all,
yes.
Okay, fantastic. Well, I was not prepared at all. Well, yeah, university doesn't really prepare you for anything, honestly. Yeah. Well, yeah, learning Scala 3 macros was again, a bit challenging, but it was made a whole lot easier by because Alex, he guided us through that. So, well, yeah, I worked on Quill as a senior project here, right? I was leading this team of 6 students, and we were working all on that. So, well, again, I feel like learning is sort of made easy by really doing it. I think. I mean, you're just sort of known in the computer science world. After you've actually built something, you realize, oh my God, how easily that build can break. So you have to figure out ways to to build it again. Yeah, which again, yeah, university doesn't really teach you. You have to you have to teach that to yourself. And well, yeah, but personally, I had to, because I was leader of the team. I had to already keep learning more and more so as to answer their questions. I had my fair share of questions too, and I actually I'm quite surprised because I'm quite surprised that Alex doesn't hate me, because I used to bother him all the time, just bombarding him with questions. And well, I mean, yeah, again, I guess to learn anything you do need a great teacher, right? And I was lucky enough to find one. Ironically, not in my university, but where I was interning. It was but yeah, so it was that was that. I mean, yeah, I quite enjoyed actually, the development process of Quill. That was fun. That was a fun bit.
Thank you. I mean, I'm honored to have had the opportunity to do that. So what are your, let's start with functional programming, as I sort of took you up through different constructs in functional programming, and as you started to use that, what were some of your thoughts, some sort of experiences that you can remember that sort of were the things, that realizations that you had, stuff like that?
Oh, actually, yeah, I think well, the biggest sort of the brain expansion meme. I don't know if I assume that everyone is sort of know of that meme, right? It was that point was your first monad talk that I had, right? I think that was literally my first day as an intern, and I had the monad talk with Alex, and I'm like, what, monads? Like I remember, I sort of remembered it from university. Did not retain anything at all.
Right, and then I said, wait a minute, you learned Haskell, right? You learned maybe monad.
I was like, but did I though? Did I? Ah, I don't know. It was, no, yeah. So again, yeah, that brain expansion was real. And it was a great kick. I love that. Yeah.
FYI, just let me say it like this. I don't know, Adam, I haven't shown this to you. I haven't really shown this to too many people, but sort of my monad talk should actually be entitled "Why You Already Know Monads." Basically, it's very different from sort of a typical monad talk. Is like, oh, here's an endofunctor. Here's an endofunctor on sets. Here's a monoid. Here's a set of monoids. Here's a monoid endofunctor. This is actually not that at all. I start with collections. I talk about collection transformers, collection flat maps versus like nested loops and if statements. Then I go into JavaScript futures, essentially get calls, and build up a giant pyramid of death and show how that reduces to a for comprehension. I might mix in some optionals, some logic with optionals, and then I introduce Quill queries. And then from those different for use cases, refine what a monad is. And I think that's coming at it exactly the opposite way. That's actually how I learn monads. Like I sort of all the endofunctor stuff, I actually learned that later. The way that I learned monads myself was I actually put on the board, like on a big whiteboard. I think I have a photo of that to this day. I put on the whiteboard every single kind of thing that used monads or was monad-like on the board at the same time. And I just looked at the pattern and I'm like, oh, all this stuff is really the same. So that was sort of my experience. But anyway, so Prakar, tell me this, right? That you started using this stuff, and you started using it at work on a daily basis. What are some of the things that you found sort of easier to use and easier to understand? What are the things that you found harder to use and harder to understand? What are some of your thoughts there?
Well, Scala, again, how to put this? Scala as a language, it was really intuitive, when you explain it to me. Again, if I go back to the meta programming part of it, I don't think it was that intuitive to me, at least. That it was really hard for me to really get into it. I think we all needed, my team and I, we all needed some sort of an abstraction, and Quill provided that, that abstract project that we could work on. So as to get a better understanding on all this stuff. Whereas at work, I don't think my employer is too thrilled with Scala, as you already know. But we still have projects, and I do enjoy my time working on those projects.
So I mean, in fact, not even sort of, we can take it into the broader scope of things, right? Because with working with Java 8 and everyone's using futures or completable futures from Java 8, or some people at least are attempting to understand that stuff. What's your take on what of that stuff are people using? What of that stuff are people not using? What's the what's going on there that you
with Java 8, or like just any future versions of Java, I just thought that they were sort of ripping off Scala. This is from my perspective, and because with map, flash map, I never used any of those in Java. I'm talking about before Java 8. Of course I didn't know about them all. I learned all of it from you, and in Scala, using in all these projects at work, and that's really it. Again, I don't think being a student, I think it's a little complicated to understand. But again, you just do a project, and then it's all just very clear to you.
Yeah. So learning by doing.
Yeah.
That makes sense. I think we need to learn sort of collectively. The question is how to teach metaprogramming, because sort of, and it has to be use case driven. I think that's the key takeaway, is the best way, or at least the most tractable way in my mind, to be able to learn how to use some of these complicated pieces of functionality is to show what to do with them. This is what you do with the metaprogramming API. This is what you do with the monadic API. This is what you do with a particular kind of tool set. That's actually another thing that's like immensely impressed me about Zio, where it's not like, oh, let's learn about semigroups, and then like monoids are an extension of semigroups, and monads are and functors are an extension of monoids, and monads are an extension of functors. Sort of that's kind of like, instead, sort of the Zio approach is, this is a database service. This is an API service. Here's how you wire these services together. Coming at it at that level, I think that's hugely important, because you can learn all about semigroups, but how you're actually supposed to create a service API with them is just completely unintuitive to even like reason about. So definitely kudos to you guys on that. So let me ask you sort of one more question, which is, in sort of functional programming, if you can remember, what's like, of all the things that you've seen, what's the first thing that you started to use on, what, or like when you worked on the schema generation project, for example, What is the first kind of construct that you found to be useful, and sort of the first thing where you started using this, and maybe like, what was the second thing and the third thing? What do you remember some of that?
Yeah, but I do. I think it was just really the monad, the map, flat map. I think I used it way too much, and then again, I never really saw the for comprehension used anywhere else. So I extensively used that in the schema generation, the code generation project. Which,
so it was in collections.
Yeah, yes, mostly, but I think mostly in collections.
Okay. Okay. Now, this was doing. So you did mostly map and flat map. You started with map and flat map of collections. Any other thing, like, did you try?
We actually also did the thing with I think with ExoSpinner, right? Sorry, pardon me.
Yeah, that's fine. That's fine.
Yeah, with another project, it was working with optionals. That was again, yeah. I used the map and flat map in that. That was I think that was a little tough to understand, but again, the monad talk it helped me.
Yeah. Okay. So essentially, that's another interesting point, is that start with collections.
Yeah.
I think start with collections. That's the easiest thing, and I think after collections, go to optional objects, and then only after you've seen that, maybe go to effect types. I think that sort of combination. Okay, this is this is useful. It's very, very useful to understand how to actually teach this stuff, because like you said, in university, you learn the maybe monad in Haskell, and you'll copy that thing from someone else, and then you'll forget about it, and that will be the extent to which you do monads in college. I think that I've got some other. The other thing is that, for example, I remember back in learning functional programming in Scheme, and then sort of the first example that I had of functional programming was doing Fibonacci, and then it's like, oh, here's recursive Fibonacci, and then it's like, oh yeah, okay, fine, and what are the runtime characteristics? Oh, it's 2 to the n for space and time, and oh, by the way, you can do this way easier with a for loop, and even more, and this at the end of the day reduces to it reduces to a simple algebraic computation. And sort of, so the takeaway, unfortunately, I don't know the professors understand this, but the takeaway from that entire thought experiment is that recursion is useless. That is literally the takeaway from that exercise. So in fact, I think that the way that people should actually start learning recursion is doing UI. Like I actually think that, sort of, draw something, try to draw something on a screen that requires something and something and something and something and something and something, and go ahead, try to do that with a for loop, and and see how far you get. I think that, and then that potentially that might be a way better way to approach this than I don't know. What do you think, Kat?
I love it. To answer abstractly, I think feedback loops are very important, and getting some kind of concrete immediate feedback for learning. Like nothing is more important, and nothing can speed up your learning process more than that. To just sort of have some hypothesis, be able to very rapidly invalidate multiple hypotheses in a row, and sort of refine your understanding of this thing. Because like code is not intangible. You cannot touch it at all. And I think over time, as you get experienced, you kind of get the sense that it's slightly tangible. Like you get better at modeling von Neumann machines in your head. You can see the little, the Turing stamp move down the line. You can kind of hear it clicking in the back of your consciousness. But that's definitely like a trained mirage that you sort of can work on over time. At the beginning, people, I think you forget that you have none of that. You just see text and a text box. It is so painfully very indistinguishable from like nonsense alien prose. It's just sitting there and it's completely indecipherable. So to make it tangible is one of the best things. And I think that's why you see like languages like, what are they called? Hackett? Well, not Hackett. They have those little like baby.
Hackett.
It's not baby Haskell. I forget what it's called, but they have a version of Haskell. Is it called Hugs? I don't know. But they have these like visual languages. That seems to be a common thing. Like these block-based, not great for writing actual code necessarily, and maybe not even. Let me take all that back. Visual feedback is great. I think if there were coding UIs, it was a very satisfying way to get started. I think that's kind of why I got into it, making things animate, making things move. And it's the drawing the turtle, making the turtle run around the screen. As stupid as that is, if you could, I don't know. I think there needs to be more work in making functional programming more tactile and more visual, because you're just so far out in the world of abstractions that there's no frictive surface around you. You cannot grab onto anything. It's just a smooth, giant granite bluff, and that you're asked to sort of just, I don't know, climb up with your fingernails, and it doesn't make any sense. So yeah, I think the problem is like Haskell and these FP languages have this history of academia in which, people are well trained and they have a sense, they know how to manipulate the abstract. It feels tangible to them because they've built the mental models. Whereas for everyone else, it's just this slick alien surface. And I think, yeah, visual coding. There's something there.
Yeah, there's.
Alex, shall we shift to the spatial chat here so that
let's do it.
we can all
Let's
join
go.
the party? All right, let me
Yeah.
paste the link here, everyone. I'm going to do it in both the Zoom as well as in the Discord, so everyone's got it. But yeah, this will be fun. We will all be able to talk to each other.
All right,
I think we need the password as well. The link,
yeah,
I think, is not enough.
Oh.
Yeah.
What's the? Do you want to paste it?
I can. Yeah. Let me find that. Sorry.
No.
Cue the elevator music.
Oh, there we go. Okay.
VJC, VJC, capital MS. Perfect.
Okay, cool. We will see you all over there shortly. Hope you can make it.
See you guys in a minute.
Bye all.
Yeah.